Hi there, and welcome to this short video where we will be exploring the topic of mechatronics, just having a quick look at what is mechatronics, its history, and try to get a good understanding of the field itself so that we can better understand the depth at which mechatronics is part of our present and is without a doubt our future. So the term mechatronics was coined in 1969 by an engineer named Tetsuro Mori. It is a field of science which researches and develops technology, which is the culmination of multiple disciplines of engineering, predominantly mechanical, electrical, and computer systems engineering, but its subdisciplines, optical, telecommunication, control systems, all contribute greatly, more so now than ever. The term itself was coined in 1969, so the idea of mechatronics has only been around for less than 50 years, so it's a very young field in that sense. And what makes it what it is, it's the interdisciplinary synergy. It has created a kind of catalytic effect for new solutions for the ever increasing technologically complex situations we face. So robotic arms, automated packaging, surveillance drones, space shuttles, even they're all mechatronic devices. Mechatronic devices are virtually everywhere. Even virtual reality is only possible through such devices. So a mechatronic device is able to process program logic and perform a physical process using its engineered capabilities. Just take a look at this man in the jetpack right now. Yes, the jetpack is using fluid mechanics, thermodynamics. It has electrical components, so circuit theory as well. But what's allowing him to control it is the mechatronic aspect. This is a mechatronic device. It has program logic. It's performing a physical process thanks to its engineered capabilities. So being able to program the logic of a process into a device is the defining moment that enabled mass automation. This was achieved with the use of a programmable logic controller, PLC. So this jetpack has a specialized digital computer, which is akin to a miniature PC tower, with its geometry and functions designed for what is clearly a more robust process and operating environment. So it has become the device's mind. It stores program logic. It's continuously scanning inputs and updating outputs. Program is written for it, perhaps in structured text, maybe even in ladder diagram format. For the level of accuracy that the pilot has in terms of control, it must be a closed loop control system, which means that it uses feedback to correct, to adjust itself with respect to the process of flight. He's able to maintain his position. He's not in a situation where he has no control. So clearly there are many subconscious processes, and there is the conscious process of the pilot controlling the system. So a PLC is very modular because for it to be able to do this, it has many modules which have either digital or analog capabilities in terms of input and output. They are able to receive these signals and update accordingly, and the sensors are communicating information of height, position, tilt, acceleration, temperature of the device, the number of minutes of flight left perhaps. So there are all these modules that are able to allow this device to operate in the way that it is, making it a truly mechatronic device. Invariably, the future of this field is dependent on research and development to create better hardware, which in turn derives designs that are greatly optimized for higher level processes. This in itself being an extremely high level process, but we also have unmanned aerial vehicles that have surpassed the need for a pilot from a remote location. So we have planes that can fly, take off and land by themselves, completely autonomous. We also have dragonflies that have been input with, that have little chips attached to them that can control their muscles through electrical impulses and are able to communicate back position and all kinds of signals that allow the observer to interface with the insect. This is a extremely high level process which requires extremely complex hardware that has been greatly optimized. So as we continue to research and develop and create better hardware, the derivative of that is going to be designs which are greatly optimized, capable of higher levels of logic and perhaps communication. In the near future, we will have processes that will themselves become much greater. It's not going to be a case of a factory responsible for car assembly using a series of robotic arms. We may reach the point in time where we're able to build not just cars but entire buildings. We could build a space station using mechatronic devices as opposed to building the device on site, on planet, and then transferring it, transporting it into space. It can be built on site in space with a mechatronic device or a whole collection of devices that are capable of high level processes, capable of unmanned flight, unmanned construction, and communication back, and able to do the task and also eliminate a previous solution to such a technologically complex situation. Make no mistake, mechatronics is not our future, it is our present. And as long as we have the need for interdisciplinary solutions due to technologically complex situations, mechatronics is going to be the answer to everything.